going. I think we should be good now. Okay. So, I'm going to do a little bit of work today on the web browser thing that we make for the MEGA65. So probably the best thing is actually to give you a little bit of a demo of how it works. So let's go back to loading our index page by default. Script that prepares all the pages and loads them. And you'll see it loaded. So now there's a problem with the TCP/IP stack which I'm going to try and work on. So I might have to do this a couple of times before it actually will load. You can see. And so I've got the mouse. This is just cheap and cheery Dell mouse I had laying around with a mouster that I got for my birthday. Cool. And so that works great. The scroll wheel doesn't work on it in the middle button yet either, so we're going to have a chat to the folks at Retro Hacks and see if they can't add support for that, because it would be really cool if they were able to do that for us. And so this is the kind of symptom that we get where the TCP/IP stack just kind of crashes. So if I go back. Oh, we've still got. Oh, I know why that's doing that. Because I had it running in a separate window. That won't help. Okay, let's try that again. View pages. Says live. Oh, there he is. Now we've got the fallback. Cool. So we can see we have something that looks quite like a 1990s web page. We have some text, we have some headings and things, we have some bold text, we have mouse control, and we have an image, and we have some links. And what you can probably see, so the mouse pointer at the moment is kind of, it's white with a bit of a red tinge, so that's not a clickable area. If you bring it over something that is clickable, it toggles between blue and light blue. So you can see the image is clickable, the link down here is clickable, and if I move off the link, it's no longer clickable in either direction. And you can actually click on the space to the right of a word, so that if you have multiple words that are linked, the moment we don't set the attribute for the underline under the space, that's window dressing to deal with later. But you get the idea. And if the TCP/IP stack were working properly, then, well, actually first up we wouldn't have these funny bits of buffer poo where it's put wrong things in the wrong place.
I've been interested in computers for a couple of years,
but we would actually be able to click on some of these links. So for example, if we prepared a lorem ipsum text page, if I click on that, we can see that it's actually, if I move my nog out of the way for you, lorem ipsum.h65. So h65 is this file format that we've made. In case you're trying to read the tea leaves of this, the plus is the point at which it's got the h65 header in the file. It's a really crude, simple parser, as you'll get to see in a bit. And then the TCP stack, especially on a subsequent page load, I think it's the round trip time estimation is going completely bonkers because of eccentricities in at least the way that we've got WeIP set up with this. And so it's going to refuse to load the page. You can see it wants to load the page, and we can actually try, if I press R on the keyboard, that will attempt to reload the page, and sometimes this works. Except what I have to do is I have to I'm just using a simple Python web server that can't do multiple pages at once, and so I have to kind of abort the half-cooked socket each time. You can see it's got to have the same place again, so we'll try again. And again, I need to. It's not quite so far again. So there's something fishy where these subsequent attempts cause it grief like this. So let's see if we can't make it actually load at least once. Yeah, so there's no plus there, so that means it's got. So there's two errors with the TCP stack that we have at the moment. One is that some segments are getting accepted in the wrong spot in the stream, so we're getting a corrupted stream. That's what's happened here because there's no plus to say it saw the header. And the other is where like it loads for a bit and then it basically just freezes up because the round trip time estimation has gone really bad. If I position the cursor on the end of that last dot, we'll see more dots come up. So there's a dot for every TCP/IP packet that it receives, and you can get these delays of 10, 15 seconds, or even just complete sadness going on. And we can have it off screen, but I can kind of watch the TCP/IP traffic and basically see that the web server, which is running on my laptop, has sent a packet some time ago, and it's not getting acknowledged, and I don't know whether that's because the MEGA65 hasn't received the packet, or who knows. We're going to investigate some of this stuff. So we'll try again to see if we can't actually get a complete load for you, because when it works, it usually just works, and we don't have massive delay. It's interesting that's kind of getting to the same spot there. Did one too many Control-C. So that's going to load the whole thing again because it's my script does that. So anyway, you get an idea of the TCP/IP stack grief that we're having. So what I might do is we'll actually go to the lorem ipsum page and we'll tell it to load that page as soon as I find my mouse cursor. And I've got my son here in the background is going to prepare us some other pages that we'll be able to display on this in the fullness of time. No, it's fine. Well, you don't know what you want to do with the page. You don't want to do anything in Pokemon or Minecraft or anything? No? Some story? No? That's the inspiration, eh? Fair enough. Yeah. No message yet. Okay, you can do scratch there if you want for a while. Okay. Okay. So let's. Oh, that's misloaded again. Here really what I want to, okay, right, so it's loaded the page up now. So this, obviously there's a page with more text. You can see that we have really nice, smooth scrolling with the mouse. And this is proportionate to the mouse movement, so if you move the mouse quickly off the bottom, it will scroll an appropriate amount. And so a page can have about 200 lines on it if they're 80 column using 16-bit text mode, which is what we're using here. But so you could in fact actually make a page that is longer if it was either only 40 column or just 80 column PETSCI or something without the extra, needing 2 characters per character cell. So you could do really nice sort of, the BBS style PETSCI art that you'd be able to scroll up and down through in here as well. So yeah, so that's what we have at the moment, pretty much. And again, we can have links back in here, but as we've been seeing, if I, oh no, that's interesting, that hasn't registered the link. You can see it's not highlighted, so there's got a funky bug happening there, which we'll have to deal with. Interesting. And I've also set up so you can press R from within a page, and that will trigger the reload of the page as well. And obviously we'll pretty up this whole page loading kind of process and have an option so you can type in a page that you want to load yourself as well. So anyway, but let's have a think about how we're going to debug this network stuff. We'll go back to index.h65. Actually, first of all, so I'll talk a little bit about this H65 file, right? So these are not HTML files. So one of the big pieces of trickery that we've done with this is that we don't have to parse the pages to display them. So the total browser, if you like, is 538 pages, lines rather, not counting the TCP/IP engine. So if I kind of go through it, see there's not a great deal. There's our mouse pointer. We have an interrupt handler and a few other bits and pieces for the TCP/IP stack. This is kind of the callback the TCP/IP stack uses for most things. We look for 4 bytes in a row that match H65 and an FF byte. And if we see those, then we start parsing for the data in the page. And what we see then is that it goes through, it's a 128 byte header, including that. So we latch from various bytes in the header, various bits and pieces. So you can set the screen color, the border color, the default text color, what page the text font comes from. So in these pages, we actually have an ASCII font embedded in the page, all 2 kilobytes because it's a C64 font, so that we can use regular ASCII instead of PETSCI. But if you set the char page byte to 10 hex, that would be uppercase. If you set it to 18, then that will be the lowercase font. And you can set some of these other key register values as we go through. And then once we've gone through the header, then the rest of the page actually consists of a bunch of these blocks that say what address in memory it should get loaded to and how long. And obviously if a block is empty, then we just abort. That's how kind of we mark the end of the page. And otherwise we actually just write the bytes into the page. So we just poke the block address with the next byte we've read, increment the address, reduce the count that we need to do. If we've got to the end of the block, we go back to the thing. So that's the page loader. It is super simple. And if we come down further, if I fetch page, right? So when we want to fetch a page, we switch to the C64 normal text mode. We clear the memory that the pages are allowed to use, which is mostly in banks 1 and banks 4 and 5, with the exception of the font has to be in bank 0. And I've put that in F1000 for now. But actually the page can set it where it wants to put it, right? Then we do the DNS lookup on the host name. We prepare our HTTP request, so it is HTTP transported, so that you can host these pages on a normal web server. And we demunge because we've got CC65 by default is doing PETSCI encoding. So at some point I'll remember the pragma to disable that, and then we'll just do plain ASCII in here. Then we create the socket, set the callback on it. We set our receive buffer with a kilobyte, which in theory should set the window size to a kilobyte. Then, okay, we're again erasing the color RAM and screen, which we're doing that elsewhere now, so we don't have to do that. I'll clean it up after. And then we have a loop while we're reading from the socket. We basically wait until we get the H65 error variable set. So that will get set to H65 done if it worked fine, and otherwise it'll get some other value. And we support some keys, so you can press R to restart the fetch while it's going, or you can press run stop or control C to actually abort the fetch completely. And then of course we disconnect the socket and close everything at the end. So if we, so that was fetch page, and then we have, so in the main function, once we've fetched a page, we then sort of apply these various register settings to set the video mode, and that's all it has to do, because again we've loaded everything into memory. The pages really are actually an image of chip RAM that the VIC4 needs to display the page, and then the rest of it is really just having some input keys to be able to scroll using the keyboard, for example, to ask for the page to be reloaded, and checking if we have clicked the mouse. And if we have, then we work out the URL, we strip the URL out into host name, port and path parts, and we do, we reset the network and we fetch the page. So that's all super duper simple. I'll go back up. The mouse click stuff is a little bit interesting in that this is actually where it works out which URL applies at a position. So once we've updated the mouse position and called scroll down to set the scroll position through the page appropriately, we then work out where the mouse position is in characters, because that's how we define the bounding boxes for the links. And we basically look through the links are allowed to live in bank 1 at 1/8000 hex. We have a count of those, it's a 16-bit count, so you can actually have up to 64,000 links on there. Sorry, my son's trying to organise a Minecraft date with a friend of his, so he'll be ready for that in half an hour's time. Sounds great. Text when ready. Okay. So we go through the list of links and we copy the bytes down from bank 1 into bank 0, because CC65 can't directly access variables in any bank other than bank 0. So we put this into a variable called link box, and there are 6 bytes in there. The first 2 bytes are the address of the URL in bank 1, and then the other 4 bytes are the top left and bottom right corners of the corners of the bounding box. So we basically just check, if the mouse position is outside the box, we skip over it and we'll go to the next one. Otherwise, we set the mouse link address to that address of the URL text, and then we copy that really just for debug purposes down to E100 in bank 0, just so that I could have a look and see that it was working, so we can actually we don't need that anymore. And that means that the link address is available in mouse link address. So if we come back, mouse link address, so when we click on the mouse, if there is a link address set, we just use it. We don't have any further processing to do at that time. So again, that's why we saw it was super responsive. As soon as I clicked, it wanted to try and fetch the U page, and then the TCP stack, of course, as we know, is balking things up badly after that. But that's basically a walkthrough of 90-something% of the entire code. We purposely designed this to be gobsmackingly simple. Now, to make a page, what I have done is we're just using a very simple dialect of Markdown, and we have a converter that converts the Markdown into these rendered pages. So at the moment we support hash and a line for heading, double asterisk delimits bold text. Exclamation mark lets you have an image. Instead of having alt text, because it doesn't really make sense for us, and there's actually no standard for having linkable images in Markdown, we're actually kind of allowing to put attributes in the square bracket section there. So href gives a link target, and then we have the link. So in fact, this page links back to itself, which is a little bit dull. At some point we should actually make a page for that. We also need to make a 404 page so that we can detect when a page hasn't been found and display an error. And then we've just got some other text with some links. In a fairly normal kind of Markdown kind of way. So what we then have to take the Markdown and turn it into an H65 file, we have this choice program MD to H65. I won't go through all of this, but essentially it sets up the, this is a bit longer, right? It sets up the memory areas as arrays and parses the text, does the line breaking, checks for the attributes, applies all of that, generates the screen RAM, generates the color RAM. If it hits a PNG image, then it will turn that into 8x8 tiles. It will deduplicate them and and try and lay that out in memory. It'll complain if it doesn't fit. Oh, hi Anton in the chat there, super. And output the H65 file. And so just to complete things, then let's have a look at an H65 file. So as I said, it begins with that magic signature, and then we've got our header that comes through to 128 bytes, and then we have the first of these 8-byte header blocks. So it's the address in little endian order. So the address for the first block is FFD 3100. That's the address of the VIC4 palette area, and the length of our region is 0300. We literally have the palette we want to use for the page being loaded directly into the palette memory by this block. This is, as I say, again, it's a gobsmackingly simple approach to doing this, but results in quite a nice effect. You can see here there's the welcome to the MEGA65 in the text here. So this is our next block starts here. So it's going to 1/2000. That's where the screen RAM is expected to be, and it's 1860 hex bytes long. And because we're using the 16-bit text mode, there's 2 bytes per screen RAM byte. So that will go through, and we can see that where we're getting this stuff here with the both bytes being used. That's actually where that image is. Showing the dev kit, and this converter program will sample an image down to 256 colors. It will do a horrible job in the process. If someone wants a bit of fun working on some C code, that would be a great thing to improve. And you can have more than one image, but they'll share the palette, and this really disgusting palette quantization code that I've got in there gets used for that. Now here we have the oops, scroll past where it gets started. Right, so here we've got the address for the color RAM, and again we have the same number of color RAM bytes as the screen RAM, and then our color RAM. So the 81, so this is the underlined and white attribute. So that's, we had index in white with an underline under it. And if we go through further, we get the right. So where's this one? So again, this is where it's showing the image. So it has different stuff in the color. Oh, here's the font, right? So we should be able to find the header for that. We should be able to recognize that. Here it is. There's our header for the font, so F1000 hex, and it's 0800 bytes long. So about 3C. You can see if you could it recognizing C64 fonts in hex or in ASCII rendering, you'll see that that's indeed one of those. And then we have the end of that, and we have the tile RAM, I believe. Yes. So here is, so this is for 40,000 hex of bank 4, and it actually includes that byte as well. And so there are BC 40 bytes. So B C D E, so about F1000 will get us to the end of that. And if we go over here, we'll actually have the bounding boxes, and the URLs will be somewhere around here. Okay, D17. Ah, there we are. Look at that. So there's the list of URLs in there. They're just as ASCII terminated strings. And so you can see it actually supports relative as well as absolute paths already as well. So the raw functionality to display interesting kind of web pages is already there. And we can improve that MD to H65 program to support PETSCI, to do all sorts of interesting stuff really, because it's just loading slabs of RAM into the MEGA65. We'll put a bit of protection so that it can't overwrite itself and other kind of critical bits of memory. And here we have another example of the this is a really good example of it balking, right? So the TCP packet that should have had the text up here is actually the following TCP packet being put in there. That's actually a clue for us as to what's going wrong. So this is this error where it's pulling the wrong data out of the TCP stream, and I'm not sure why. But we'll investigate that. I'm curious as to whether every link. We saw that other bug where that link at the bottom of the page. There is something funny where at the bottom of the page the converter is not outputting the last paragraph or the last token or something. I need to try and figure out what's going on there, but it's manageable for now. But anyway, so that's a walk through how it all works for the time being. So we need to try and debug, as I say, what on earth is going on with the TCP stack. And what I'm thinking about doing for that is to modify the browser software so that whenever we receive or send a packet, we actually write the packet out in hex onto the serial monitor interface. So it's effectively doing like a TCP dump for us of all of the traffic, so that we can see from the MEGA65 side what it thinks is going on, and then we can compare that to a TCP dump from the server side and see whether they're both agreeing on all the packets, so whether we're getting packet loss on the link. Because I'm actually running over a Ethernet over power adapter, which they're not really renowned for not losing packets. And we did have a problem previously where the MEGA65 Ethernet adapter was occasionally botching frames. But I'm pretty sure that second problem has been fixed. But we'll find out for sure by making this packet debugger in there. And I'll probably add it into our BIP, so that you can basically just set a flag that says that you want for all network traffic to be logged onto the serial monitor interface. So I need to go to view. So we need to go into the Ethernet driver. Actually, I should change that. This is Ethernet management for the MEGA65 45 GS100 integrated Ethernet. Controller or compiler CC65. So we'll have a static unsigned char ETH log mode. We'll default to an unside char. That won't really help us much. Okay, Ethernet log mode. Now what we want to do. Aha, packet is available. Right. So if ETH log mode, well, actually set it so you can ETH log RX extern unsigned char ETH log mode hash define ETH log RX1 hash define ETH log TX2, so it will be bit fields, and you'll just be able to set either of those bits if you want to log in either or both directions. So enable logging of Ethernet activity to the serial monitor interface. Okay, so what we want to do, we need to display some information about the time that the packet was sent. Actually, what we also need to do is we need to include, there is a MEGA65 libc. We have a routine that will let us, I think it's a debug message. We can actually just write a debug message. And this will go to the serial monitor interface. Yes, cool. So we can actually just format up a string and we can just chuff it straight out to the serial monitor interface. Debug.h ETH log mode. Okay. Debug message. Now, timestamps would be lovely to have in a really sophisticated manner here. We do have a real-time clock on the MEGA65, so we could put that in as well for good measure. Maybe I will. As long as we don't run out of RAM. Yeah, so Anton's just said that there's a constant humming, low-frequency noise in audio. There is at the moment, and I don't know where it's coming from. I'm just going to try and turn off the... So while I'm talking now, I've just turned off the parallax audio feed, which is actually coming in by 3.5mm audio jack. And I'm wondering whether that's not the source of the hum. It might be, or it might not. So I'll turn that back on. So you can let me know whether that disappeared. And now I'm going to turn off the microphone here and see whether it's the microphone here that's actually causing the hum, because this microphone also actually comes in by 3.5mm audio jack, and so it's possible it's picking up there. So I'm just going to, you'll get a few seconds of silence. And okay, yep, so it's the mic. Let's just try, does that get rid of it? It's a question of us working out what is causing the where it's getting picked up. So I'll have to have a look at where I route the microphone cable. It is quite long and it's going all over the shop, so it's, in one sense it's not super surprising that it's picking up some 50 Hertz hum, and it goes past power cords and all sorts of fun stuff there. So yeah, I'll try and have a look at that before the next stream, all going well. Okay, so let's need to remind myself what a TCP dump output looks like. So the more commonality we can have, the better. Okay, so we have a timestamp, hours, minutes, seconds. Okay. This wasn't so. Percent O2D, percent O2D, percent O2D dot, and then we have the fraction of a second. Now, it would be great to have a real fraction of a second here. What we have instead, the easiest way for me to do this is actually to get the number of VIC4 frames drawn, and we can then multiply that out. What I'm going to do, because it's not directly comparable, so I'm just going to put the slash with the number of frames at the end. Peak. Oh, it's D7FA. Debug message. Debug message. So that will display the frame, and then we want. We're going to do this after we've got. We want the length. We've got the length already read out somewhere. Somewhere, I'm presuming that I've actually had to pull the length down. Apparently not. We could actually just be really crude and just assume that every packet is 256 bytes long for the purposes of our debug. That's probably actually not a big problem. Try and do this efficiently. So one of the CC65 is annoying in that the code it produces is really big and flabby, and we're running at close to the 38K C64 basic memory layout limit. So to be conscious about how I do these things, probably the easiest way for us to do this is to copy down the ETH-RX buffer plus 2L plus I. We just want to copy this down to somewhere convenient. That's not going to cause grief. We'll just have a variable 16 bytes. Printf debug message 82 through len debug message comma. So that will put our 16 bytes on the end. Those we put the, what's probably easy more so we do debug message, and then debug message So let's see if that compiles. Oh yes, we haven't defined debug message. Char debug message 80. Unsigned char 16 bytes 16. And we don't have I and J defined. Unsigned short I, unsigned char J. Incompatible pointer type, the debug message. Ooh. So that's a char. Incompatible. 1125. Ah, okay, right. So here's where it's. Oh, yes. Ah, because it's not debug message, it's debug message. Which means that we presumably have got a debug message. I'm going to read someone else find that. Oh yeah, left off the closing square bracket here. Are we under the... Oh yes, we're under 38k, so that's all good. As long as this 37547 is below 38911, we should be okay. I'm not sure, it might be out of work if it goes under basic, but we'll find out. So let's go to fetch.c. And we're already including WeIP, so we can go main, and we can say ETH. ETH log mode. Log RX or ETH log TX. Enable logging of Ethernet activity on serial monitor interface. Okay, now brief interlude while I set Minecraft up for Sun. Okay, disaster averted. Minecraft is running, so we're all good. Right, so where were we up to? That's right, so we were telling it to do that. So in theory, we have now a version that we can do this. Oh, look at that. Packety goodness. Isn't it nice when things work the first time? And this will be because of blasted Petsky conversion. ETHRX, let's change it to ETHRX, and now let's actually put the real-time clock info in there. I should that load it's screwed up quite fantastically. It must have corrupted a packet loading into the font, so the font is all rubbish, even though most of the page is actually okay. It's just a little bit funny looking. Now we have time.h, yes. So we actually have a mechanism to get the real-time clock on the MEGA65, also using our MEGA65 libc. What do we after here? We want struct M65 TM and then do get RTC TM, and then we can do TM hour, TM min, TM sec. And now we should have proper timestamps. We've changed this to lowercase so that the Petsky conversion should be okay. Now we're getting extra lines output between everything. That's the other thing going on here. I presume it's between. Interesting, so it's not between there. So why am I getting an extra line? Let me have a look at that debug message routine. Maybe it puts a carriage return on the end. It does put a carriage return on the end, so that makes our life super easy. We can do that. And in fact, if we want to, we can have a blank line between each. Just by doing that. So then the packets will be a little bit easier to see apart. Okay, we'll get that ready. Let's get it off. Struct pointer expected. Let's have a look here. Yes, right, because it's actually not a pointer here, it's actually the real thing. Okay. Okay, so now we can show that. Oh, look at that. So it's loading. Okay, and again, we've got some botched up stream stuff, but that's fine because now we're going to start being able to debug some of this. And yep, we can see that the time state is changing, but that one's not. Maybe I've got the wrong variable frame. Let's see, D7F A, I thought it was. Yeah, frame counter. Let me have a look at it. Yeah, D7FA. That should be working. It looks like it's working. Make sure that our memory map sorry, D7FA we want. So I'm just querying. So when we do a 28-bit address that starts with 777, this actually queries it in the current CPU context. So that looks like it should be fine. So what other curious bug have we got happening here? So I just find it hard to believe that all of those packets coming in were no, that's totally implausible. We've got our Ethernet frame there, so that's all good. Convinced that it's actually got anything sensible in it. Might do log one of those to a file, t etherrx.log. Run it again. Okay. So this will display it, but it will also log it into the file. Yeah, okay, so now we are getting packet contents through this, so that's all good. That is still a mystery as to why D7FA count the number of elapsed video frames. Oh, that's quite curious as to why that's not. Let's read that. Let me actually just try. What I'm going to do is we won't peak it that way. We'll do an L peak on the full 28-bit address, FFD37FA. So the FF is the IO megabyte, D for the kind of the things that can appear in the D1000 range, and then if that was a 0, we'd be getting the C64 IO context. If it was a 1, it's a C65. If it's a 3, it's the MEGA65 context, because it's possible that we've actually set the memory banking when that's running to have the Ethernet frame visible there. I'm not sure, but it's possible, so let's just try that again. So as soon as that switches to the web browser, yep, we want to run it there. Nope, still showing 0 for that. It's quite. This is something balked up in the. Let's do a plain %d and see whether that actually. Well, and %0d and everything has to work anyway, right? So we've got hours, minutes, seconds. This is very, very weird. Because it would be nice to have something to have an idea as to roughly how far apart the frames were in time within, inside of second granularity. Actually, do we have? I don't think. I'm just going to check whether our real-time clock had sub-second granularity. I don't think that it does, which is a little bit sad. I'm just going to try and quickly reroute the microphone cable. Interested to know whether that has affected the hum volume. Okay, I just need to do one more tweak with this cable. I'd be interested to know whether that has reduced the volume level of that hum, or hopefully maybe even eliminated it. We'll find out. There's so many cables hanging around here, there's plenty of source for ear noise to sneak its way in, I'm afraid. Okay. Yeah, I'll have to have a bit of a hunt around. When I was... Okay, so is it still there if I do that? Is it changing at all? Is that any different to it if I'm doing this? What I'm literally doing, I'm just fiddling where I get the audio take out. Yep, turn the radio off. Okay, let's. So if I. So it's also possible that it's coming in through the USB lead into the microphone. Oh, it changes it. Okay. Oh, it's gone, is it? Or is it back now? If I'll squish it in, is that it's humming or not humming right now? Okay, and if I, how's that now? Still there? Yeah. Okay. I'll have to have a think about what I can try and do to eliminate that. It will just be 50 hertz hum. It might even be possible somehow in either the ATA Mini Pro or in the in Twitch to cancel that out. Oh, now my voice is bad. Okay, right. Okay, hopefully it's fine again now. I might try and get a decent shielded cable for the for that, and get a shielded USB A cable as well. Is that US? No, my gut feeling is it's coming in the power, because the power goes across the back, where out of the way of everything on my desk, but there's stacks of power cables and things over there. That's right. I'll try a couple of experiments later with that. But anyway, back to this mystery of why on earth is it not working. Let's just try hard coding a number in, right? And then if that doesn't show up, then we know that we've got something else going on. Okay, so the 42 shows up. So this suggests to us that it's reading something. Okay, let's go peak 212. So this will be the raster line instead. So we should be able to get something from that. Yeah, so it's reading the raster line fine, right? Because we're seeing that varying. So why on earth is it not being able to read the frame counter? Because the D7FA, because I don't think you can actually even reset this frame counter. It just counts frames. Ah, that's why. Yes, whenever you return from a hypervisor call, like print a debug message, it zeroes out. Yeah, and that's so that you can't do timing attacks on hypervisor calls. Shmee. Okay. The raster number's going to have to do for us. And probably what I should actually do as well is set the real-time clock Isn't that nice with the real mouse and the mouse in here as well? Chipset. Okay, real-time clock. So we are 15, 21. How many seconds? This is going to pain the bum to. Linux is not going to give me the look now. The current time. Just in a browser, 3:21. The exact time, right. 21. Okay, so I need to 15, 22, 30, 27, 25, need to wait until it gets to 30 seconds. Clock counter here. Right. Oh, that's okay, fascinating. It actually sets it, when you hit the last digit on the end of the line, it seems to be I think it might actually when I hit the digit 30, right. Okay, we're within a second now, which is really as much as we can hope to do. Go back to RX log. Just wonder whether that's actually on the same frame or not. I suspect it's not, but it's curious because it's only 11 masters apart. I think that's well, unless there's rubbish coming on the oh no, it's the address just right because our MAC address 30. Anyway, so now we have, that's debugging receiving frames. Now what we need to do is to have much the same for sending frames. Each packet send. This. So, paste that code in there if we're doing it TX. TX. And now we can just copy We actually have TX frame buff already set up for this. Great. TX frame buff. I plus J. With TX len, we can match exactly the length of the packets. It would take the 16 byte residual, but that's fine. It will always show to the end of the row, even if there's not really the packets there for it. In theory, that should work for us. Oh, I need to include time.h. Well, I am. Oh, so we've got it. Oh, yes, right. We already have TM there. 64. Oh, that's the RX one. Paste. Incompatible times. Now I'm confused as to what's going on. So he just complaining about static declaration for his non-static declaration. Okay, well, let me fix that one first. External static. Oh, no. Or is it static extern? Apologies. Right.
Sie hören Radio Parallax.
Nope. Okay, we just have to live with that warning. Okay. East.c line 123. 123. Sorry. How did I put that in there? Clearly be the error. Not sure. I must have mashed some random key. Let's move the TM dot in the line. Okay. Right. So let it run through. Yes, this is interesting. So just spotting there as it's going through, there's some ARP requests from the laptop, again asking for the MAC address of the MEGA65, which says to me that there's some packet not being received. It's got some reason why it's timing out and thinking that the MAC address might have changed. Okay, so I'm going to stop that because what I want to do now, third tab, sudo if config, sudo TCP dump -ni wlp10 source 192.168.178.60 or destination. So this is going to log all traffic to and from the MEGA65. I have to remember the right. Yep, okay. So that's looking good. So I just did a quick test to make sure that that log is capturing. TCP dump.log. That we can start already. Start it so that we have no packets. Now it's going to reset the MEGA65. Okay. Now that's running, and it's going to display for us the packet bodies of what it sees. We can run that only once we've connected to the MEGA65. Oh, I did it too soon. I was trying to make sure I didn't miss any initial packets. Now we're good. So it changed its IP address. I'm not seeing any. Oh, there we go. Now we're seeing. Packet. So this connection is actually barfed. And of course the MEGA65 doesn't actually have a packet filter, so it's seeing traffic to any and all MAC addresses on here as well. Okay, so I'm going to stop and restart that. Stop and restart that. Okay, that's ready. Run the fetch. Okay, that's better. Now we have a connection where it's actually transferring data. It's still getting stuck. Like it's not going at the full speed that it should. So that should still yield us useful clues as to what on earth is going on. Okay, and we actually had some segments end up in the wrong places. That's fine. We're less worried about that just at the minute. What I'm interested to do is to so we'll quit out of that. So we have our TCP dump.log and we have our eth.log. and we can have a look at those. TCP dump. TCP spell it in. Okay. So we have an ARP request, one ARP request for the MEGA65 to get its own IP address. Oh no, sorry, hang on, actually this first one is... Okay, so this is just idle ARPing. Before we go on, then we have ARP request. So this is the MEGA65 asking now for the laptop's address, because there's our MAC address of who he's asking, but actually it's kind of nice having it, put the MAC address on the MEGA65 on this one to be something that shows up in the hex dump really easily. And so at this point, the MEGA65 has ARP. Eth.log. So to broadcast from there, so this is actually the ARP request from the MEGA65. And so it's sending that several times before it gets a reply. So that's a broadcast packet. What we want to do is to find one that's addressed to us, because we're still sending ARP requests after. So this is one of the things that we've spotted actually, is that the ARPing process seems to take often a long time, and my theory on that is that that's because this Ethernet over power adapter is dropping frames, and it could be that that's actually a large part of all of what's going on, although that said, it should still be able to handle the situation much more gracefully. So we should be able to see the point at which we want to do is to line up the timestamps, right? We want to know what the difference in time is to be able to line these things up. But actually, really, what I would like to be able to do is to make a PCAP formatted file from the MEGA65 capture, because then it could show the protocol information, so that we can see exactly where it's going wrong in terms of the with the TCP handling and all those sorts of things. Because what we can do now that we have the debug message thing, we can actually print out other messages actually from the MEGA65. This would actually be good to say when we're accepting a segment to go into a given position in the stream and those sorts of things, and that will then show up hopefully, because we can see which segment it most recently received from the packet, and go, okay, right, okay, well, that's the point at which it's got confused, and get some clues as to exactly how it's got confused and what we can try and do to fix that. So, wondering whether I should do that straight away, because otherwise we kind of needle through the haystack. PCAP file format. How hard is it going to be to make it a PCAP file format? So it's a global header. Might be too hard to to do. So, which way shall I do it? Do I pcapify it so that I can feed it through things? And if I do that, really I actually need to capture the whole packet rather than just the first 256 bytes.